All right, the answers here. -3 cubed is -27, and -3 squared is +9. So together those make a -18. The next one, 4 squared is 16. So, and 8 plus 8 is 16, so that we would have had 16 times 10 to the 16, but we need to have that decimal in the appropriate spot, so what that is 1.6 times 10 to the 17. Okay, this one, what you do is you kind of go, okay, this is 81 over here, and this is 9m, so 9 times something equals 81. That would be 9. Okay, converting, divide by 5, multiply by 9, and add 32. And there we go. 150% of 3,000. 100% of 3,000 is 3,000, so 150% would be 3,000 plus half of 3,000, which is 1,500. So there we go, 4,500. And then add that to 3,000, and you get 150% more than 7,500. Okay, I'm kind of frustrated because the printing job did not show the grid. I tried to have grids on these, and they're not there, which is quite unfortunate. So we're going to have to improvise and use a straight edge, okay? Or if you are a perfectionist, you can try and do these on graph paper, okay, and attach it. But I am leaving that up to you and your parent, okay? So make sure you have time to do it. All right, what it says, this is called graphing linear inequalities, meaning they have this sign to it, okay? So we're going to graph all the pairs of numbers, x and y, whose sum is less than 10, okay? So what we first do is find all the pairs that equal 10, and we call that a boundary line, okay? So meaning x, like if x and y were maybe 1 and 9, 0 and 10. So I can even show you. We could say x is 0, y is 10. That equals 10, right? 1 and 9, 2 and 7, and so forth. Not 2 and 7, don't call me. It's 2 and 8, 3 and 7, 4 and 6, 3 and 7, again, whoops, 4 and 6, we're going to go up. I'm a little sick, so I'm not firing correctly here. 5 and 5, 6 and 4, 7 and 3, 8 and 2, almost there, 9 and 1, and 10 and 0. Now, here's the nice thing. Do we have to find all these points over here? Let me show you. 2 points make a line, right? So let's go ahead and do 0, 10, and 10, 0. Okay? 0, 10 is here, and then up 10. So put a dot up at 10. Okay? And then the next one, 10, 0, is out to the right, 10, and right here. Okay? And here's the cool thing. If we draw a line, it covers all of the others. So like if we did 9, 1, that would be, if we had the grid, we'd see it. But they end up all landing on a nice line. But all you need is 2 points to make a line. And we know these are linear. Okay, so what we're going to do is draw this. And this is called a boundary line. Okay? And notice I went into the other quadrants, because these aren't all the numbers that add up to 10, are they? What about -1 and 11? Does that equal 10? Yes, it does. And what about, -5 and 15? So as you'll know, they negatives always are part of it too. So that's why we have a line that goes on and on. We call this a boundary line. So what we just graphed really was this line here is x plus y equals 10. That's what we graphed. Okay. For graphing a linear equation, we get to do something more fun than that. Okay. We get to do some coloring in. So if we're saying we need to graph all the pairs of numbers whose sum is less than 10, we are either graphing on this side of the line, we're either going to color in this side of the line, or we're going to color in this side of the line, okay? And the guess is if the sum is less than 10, it's probably going to be below the line. So what I'm going to do is pick a point here, okay? I'm going to pick, and the book picks the point 2, 5. And we're going to, it's called your test. Okay, so go ahead and write 2, 5, and test it. Okay, if it works, then we shade this side. If it doesn't work, then it probably means we shade this side. And we could check another number. If it doesn't work, we could check an ordered pair up here, like 6, 8. Okay, and I'll even do that to show you what would happen. We're going to test that and 6, 8. And what I mean by testing is we're going to plug these points in to our equation, and we're going to check to see if it's true or false. Okay, so our equation, or our inequality, was x plus y is less than or equal to 10. So our first test was 2 plus 5 is less than 10. Let's check. Do a little question mark. 7 less than 10. True. Okay, so what we just checked was that is true, right? So that means that we're going to shade below the line. Now let's check what if we had picked 6, 8. That would have been 6 plus 8. Is that less than 10? That would be 14, less than or equal to 10. False, it's not. Okay, so that one did not work. So that is not part of the graph. So what we do now is shade. We're going to go into this a lot more detail next year. You can take a different color too if you'd like to make it a little more exciting. And you just shade this side of the line. So that means that any point you pick down here, even 0, 0, will meet the criteria of x plus y is less than or equal to 10. All the ordered pairs, all the points down here, even fractions and decimals, these all will fit this equation or linear inequality. Okay, let's try another one. We have every day Angela runs and or walks for 15 to 20 minutes. Write down inequalities for Andrea's running and walking time and graph the region that satisfies both inequalities. Okay, so what they're saying is she runs or walks for either 15 or 20 minutes, okay? And I'm going to do this. Let x equal number, I want you to write this, of minutes she walks, okay? And y be number minutes she runs. Oops. Go ahead and write that. This is called defining the variable, okay? So let x equal the number of minutes she walks and x be the minutes she runs, okay? So is she walks, the number of minutes she walks plus the number of minutes she runs is going to be either 15 minutes, and also x plus y, she could do it for 20, okay? So we get two equations for this. She could either run and walk for 15 or run and walk for 20. Okay, so, but they said she doesn't actually run, it's between the two, right? So let's now change this inequality. She runs for more, either 15 minutes or more, or less than 20 minutes, or equal to 20 minutes. Okay, so I hope that makes sense. She either walks for at least 15 minutes, up to 20 minutes at the most. Okay, so we're going to graph these things, and all the points in between will be, so these are their boundary lines. Okay, in fact, the boundary lines, let's write this, boundary is x plus y equals 15 and x plus y equals 20. So we graph these boundary lines first, okay? And let's see, we need to find points that add up to 15, okay? So how about x is 0? Well, this doesn't go all the way up to 15, does it? How about, oh, I do want it to go up to 15, don't I? I want them to go up to 20. That's unfortunate. In the book, they go up that far. So let's redo this and have it go up by 2s. So like this is instead 2, 4, 6, 8, 10. Does that make sense? So change, double everybody. Now, we cannot go into the negative zones because we're talking about time. And time cannot be negative. You can't run for negative 20 minutes, right? Sometimes it feels like you are, but we're not. Okay, so if she, X and Y, let's say she walked 0 and ran for 20, or sorry, 15. There's a point, right? That works. So we have this point right here, 0, 15. Okay, or she could do 15 minutes running, 0, or 15 minutes walking, 0 running, and that would put us out to here. So we have 2 points for our first boundary line. Okay. The book also has this, so if you get confused, please write down if you get confused, and we can talk about this in class next week as well. Okay, so now if we have it equal to 20, we would have 1 point could be 0, 20, and the other one would be 20, 0, okay? And so that would put us right here and right here. We're going to graph that. Okay. So all the combinations of her running and or walking for more than 15 minutes and less than 20 is probably in this region here, isn't it? That would be my guess. It's in between. So let's just check and make sure we find a point that satisfies both of these. So what if we went out to 10 and up to, let's do 10, 8. Okay, let's test 10, 8 with these. Okay, so 10 plus 8. Is that greater than or equal to 15? I don't know why I wrote 18. Sorry, guys. Is 18 greater than or equal to 15? True. And so that's, we tested it with that. And then we're going to test it with this. Is 10 plus 8 less than or equal to 20? Is 18 less than or equal to 20? True. So this point was true for both of these. So what we do is graph this little area. So we're learning how to graph different kinds of data here, where there's more than one answer options. Okay, so it is totally different. We're going to do this a lot more in algebra. So that was just a quick view of it. Now you're going to have some for practice. Okay, so go ahead and try these. And the one thing that they don't tell us is what to do if it doesn't have an or equal to sign. Okay, I forgot to tell you about that. I want you to notice that on the bottom of page 800, sometimes these lines are dotted. Okay, it's a dotted line if this little line is missing or this little line is missing. Okay, if it doesn't have the or equal to, your boundary will be dotted. It means the boundary doesn't actually get to play. Okay, and they have an example of that on the bottom of page 800. And letter A is going to have that happen. Okay, so Jan thought of two numbers whose sum was greater than 5. So she basically said there's x plus y is greater than, whoops, not or equal to, is greater than 5. Whoa, I'm having trouble, sorry gang. X plus y is greater than 5, okay? Write an inequality for the above statement. Well, we just did that. and graph the inequality on a coordinate plane. Okay, so what we could do too is, so we're going to do the boundary line with if we have it equal to 5, right? That's our boundary line. The only thing though is this has no or equal to, so we need to tell ourselves this is going to be a dotted line. Okay, so we could have 0 and 5. We could have 1 and 4, 2 and 3, 3 and 2, 4 and 1, and 5 and 0. Okay, there's all our points. And I'm going to pick 2 of them, 0, 5, and draw that in right there, and 5, 0. Okay, and because we could also have negatives, could we say negative, I'm just going to show you this, if you had a negative 2 for x, negative 2 and positive 7 actually make 5. Okay, so we'd go negative 2, and let's just check that. That would be up to here, and yes, that looks like it would be part of the line. Now, like we said, it was dotted line because this is just greater than. That means these actual points here would be false. 0 plus 5 is not greater than 5. 5 is not greater than 5. Okay, it's equal to. So that's why we have a dotted line here. Okay, because these points that I just graphed do not actually make up something greater than 5. They actually equal 5. Okay, so now we have to figure out which numbers are greater than 5. The ones down here, if we graphed in, shaded in here, or shaded up here. Now usually when I see the word greater than, I'm thinking above. So I'm going to pick a point above, and why don't I pick 5, 5? Okay, is 5, and let's see, is 5, 5, 5 plus 5, is that greater than 5? Yes, 10 is greater than 5, so this is part of our graph. Okay, so that's what your graph looks like. Like I said, you could do it in different colors. Okay, all right, the next one, Alberto thought of 2 numbers. He said their sum was 8 or less, but the neither were negative. Okay, graph the set of possible solutions on a coordinate plane. So he said their sum was 8 or less. So x plus y was equal to 8 or less than 8. Okay, so we know this is going to be a solid line. Write that down right away so you know. Okay, and let's think of some combinations that are equal to 8. How about 0, 8, and 8, 0, right? Those equal 8. 8 plus 0 and 0 plus 8. So I'm going to find those on here. This is 8, 0, and this is 0, 8. And I have a solid line. Now, am I going to go up here? No, it says neither of the numbers were negative. So we're going to stop at these points. Okay, we don't extend it past those points because then we would be in negative country, right? So there we go. And we want them less than or equal to 8. So are we going to pick a point up here to try or a point down here? Let's try 1, 1 and test 1, 1. Is 1 plus 1 less than or equal to 8? True. Yes, so the test, it's true. So this is part of our, we call it basically our solution zone. Okay, so you get to just draw a little triangle here for your answer. All right, last one. Ruthie, I didn't make that up. She's actually in the book today. Ruthie spends at least 2 hours reading or studying math every day. It does kind of sound like the Ruthie I know. Pretty awesome. However, she spends no more than 3 hours on these activities. So this one's going to be like example 2, okay? Using x for the numbers of hours spent reading. So we're going to say let x equal number hours reading. Okay, and y equal number hours doing math. Okay, and she spends no more than 3 hours on these activities. Okay. But at least 2 hours. So I was looking for that. So x plus y, she does at least 2 hours. So at least greater than equal to 2. At least 2 hours. Whoops. But no more than 3 hours. Okay. And these are or equal to. She can spend 2 and she can spend 3. It doesn't say less than 3 hours. It says she up to 3 hours. Okay. So we have two equations we're going to graph here. And their boundary equations are x plus y equal 2, x plus y equals 3, and these are solid lines. And as you know, these are, you could have 0 plus 2, so x could be 0, y could be 2. Okay, I'm going to graph 0, 2, and 2, 0. Okay, and it also says, write inequality for the first sentence and the second sentence. So that's these two things, right? Then in the first quadrant only, that means just up here, graph the region that satisfies, because we don't do negative time. She's not reading or doing math for a negative amount of time. Okay, so those are the 2 points for that, and then the 2 points for this are 0, 3, and 3, 0. So it's going to be a very small space here on our graphs. I'm going to do those lines. Do and there. Okay. And you know we're probably going to be between them, right? So what if we tried graphing 1, 2? Would that be right here? Actually, 1, 2 would actually equal 3. So we could do halves, or you can just trust me that it's in between there. I think we're good with that today. So this is what we're going to have for your tiny little graph. Okay? And that is it for this lesson. And we will only have 6 more, gang. So hang in there. Remember, finish strong.